till I get my money right. La 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 la, then you can't tell me nothing, right?
Our project shows two examples of Newton's first law of motion. Our experiments include how long it takes to stop a vehicle moving 25 miles per hour to a complete stop using various weights. We also test to see how quickly a four-cylinder vehicle can accelerate at a distance of 150 feet.
Our first example of Newton's first law has to do with acceleration. In this experiment, we will be using a four-cylinder manual transmission Jeep Wrangler. This vehicle is very lightweight and has a great acceleration rate due to its manual transmission. To start the experiment, we will be testing what the max speed is for this vehicle with the weight of only one person for 150 feet. Then after that, we will add another person to the total mass of the vehicle. We will continue this trial method 4 times to get a good spread of data. The variable that we are changing in every test is the mass. The mass will affect the overall velocity because it will make the vehicle accelerate more slowly. Our first acceleration trial is with one person for 150 feet. The top speed with one person was 31 miles an hour. Now we will test it with two people for the same distance, 150 feet. With two people, the top speed was 28 miles an hour. Now we will try with three people. The top speed of the vehicle with three people is 25 miles an hour. Now we will try 4. The vehicle's top speed with 4 people in the car is 21 miles an hour. These trials demonstrate inertia. In conclusion, the vehicle's acceleration is affected by the added weight in each trial because of inertia. The equation for momentum is P equals mv. Therefore, the more mass, the less the vehicle will want to move. Now we will test what effects inertia has on braking distance.
For our next experiment, we'll be covering stopping distance. With a moving object, the more weight it carries, the more momentum the object has. With more momentum, it takes longer for the object to stop, which is why it takes a semi-truck much longer to come to a complete and full stop than it does a 4-door sedan. The more load a vehicle carries, the harder it has to work, the longer it takes to accelerate, and the longer it takes the vehicle to come to rest. Therefore, this is an example of Newton's first law of motion, which basically states that an object in motion tends to stay in motion, while an object at rest tends to stay at rest. Now math comes into play. The equation for momentum is P equals mv, which means the momentum of an object is equal to the mass multiplied by the velocity of the object. While keeping the velocity constant, the more weight we add will increase the stopping distance due to the momentum. For our first trial, we will be testing the stopping distance with only one person. With the weight of only one person, the vehicle is able to come to a stop in 27 feet. For our second trial, we'll be testing the stopping distance with 2 people in the vehicle. With the weight of 2 people, the vehicle is able to come to a stop in 32 feet. For this trial, we'll be testing the stopping distance with 3 people in the vehicle. With the weight of 3 people in the car, we were able to come to a stop within 49 feet. For our final trial, we'll be testing the stopping distance with 4 people in the car. With the weight of 4 people in the car, it took the vehicle 52 feet to come to a complete and full stop. In conclusion, a vehicle with more weight will take more time to come to a complete stop because there is more momentum pushing the vehicle forward, so the brakes have to do more work to displace the momentum of the vehicle.